All right, this week in lab, we would normally do our biological molecules lab, but we are going to substitute some other activities. But I want you to be able to see this test, this first test that's in the lab for testing for organic molecules. So we're going to basically cook them, heat them up, and watch what happens to determine whether it's an organic molecule or not. So we'll have salt, sugar, baking soda, and meat. So make some hypotheses about what you think is going to happen, whether these are organic molecules or not. We'll start with sugar. So we'll start heating this up in the pan and observe what happens. I don't have test tubes, so I'm using these little aluminum boats. That's one of our alternate procedures for the lab as well. So you can observe something starting to happen.
It's melting.
My phone's getting hot. Then you can see some gases escaping and some color changes occurring. All right, so this, if you've ever accidentally burned sugar in your cooking, then this might be something that you have seen before. All right, so pretty much that's what's going to happen. So this indicates that that is an organic molecule because we see this black residue and we see gases escaping from it.
Oh. That's more like of a
All right, let me get it out.
brown, dark brown.
Well, it becomes black the longer you cook it, right?
Oh. Everything turns black the longer you cook it.
All right, now let's try the salt and see what happens. Not a lot going on yet. We'll watch it for another minute. Normally in the lab, we heat it up for about a minute. I'm getting just a little color change on this salt. Probably some of the additional minerals that are in it. Pure salt probably would not do that. So it's not changing in the same way that the sugar was because salt is sodium chloride, which doesn't have carbon in it and is not an organic compound. So I think we can stop this one. Now let's try the meat.
Oh.
And of course, if you've all cooked meat, you probably know similar what's going to happen.
Starting sizzling.
Contact a little better. All right, some of the pieces that have better contact with the surface are changing color, turning brown and eventually black, of course, if you burn them. I'm sure you've probably burned meat before. you have some experience of what that looks like, and you get some gases coming off of it as well. So of course, meat is organic. That black residue that you start to see where you've burned your meat is the carbon in the meat, just like charcoal is burned up carbon from trees, from plants, wood. And then the gases that are escaping are all the other atoms and molecules that are in the organic compound. Change this.
Oh no.
All right, let's try one more with the baking soda. Our boat is rocking there. Doesn't want to sit still. There. And probably not a lot is going to happen to our baking soda, but we'll watch it for another minute. This baking soda is also, it does have carbon in it, but it is not a organic compound. It's bicarbonate. So one of the few things like carbon dioxide that has carbon in it, but is not an organic molecule. So the questions in your lab ask you about what that black residue is and ask you about where all of those other molecules, all those other atoms that are found in organic molecules go in this process. So think about those and let me know if you have questions.